Welcome back to the Workshop of Broken Dreams. It's time I made a probe for my CNC mill, so here it is. Stick around and I'll show you how we made it. Right, so here we are. What we're going to make is a replacement probe for this one on account of the fact that this one doesn't work and is crap. So I've done some drawings. Who knew I could do drawings? That surprised even me. Right, so as you can probably see, my printer's going through its rainbow phase. It's putting rainbow colours over everything, but yeah, we won't worry about that. So I've got some bits and pieces. Here's a phono plug socket that fitted on the original probe. After a bit of circling about, I finally found the tap for it. It's a 1/4 by 32, which is this one. So yeah, I don't have many imperial taps, but luckily I do have that one. Right, and we're making it out of bits and pieces that you've probably seen before. Here we have the ground precision toughened bars that I get out of DVD players, and I've got some balls from a buggered barium, a spring I found in the scrap box, various bits and pieces, some upcyclium, some scrap binium, and repurpose them. So, oh, and some new plastic, and also a new bag of screws. Don't like new, expensive. I'm going to start with a simple piece. This is the body, so that's out of this. This is how I'm going to get to bore this tube out to 45mm exactly, which is drawn on a plan. I've got the tool, the boring bar, butted up against the outside face, and I've put my one of my DTIs so that the carriage will butt up against it. And there's 45mm of gauge blocks, and I've lined it up so it's 0 on the DTI. So I should be able to crank the saddle all the way up until I reach 0 on there, and I should be fully 45mm deep in there. Spot on. Didn't realise, but the DTI actually collides with the bottom of the saddle, so I'll have to reposition it. Repositioned and changed to a different indicator, so we'll have another go. Okay, that's a bit wobbly, but yeah, that'll do. I'll bore out the rest of it then, and then we'll meet back here. It's fully bored out now, and it's to dimension inside. So I've given it a little bit of a polish on the outside. So now it's a question of cutting it off at the right length. So if I mark that there. What? What do you need now, eh? You don't know, do you? Got a bit of beer can packing strip so I don't mar up the finish. Behind it, I've temporarily got a piece of 3mm parallel, and we're butted up against that. So I need this to be 53mm long. So if I set it to 53mm plus the 3mm there, 56mm, then I can just keep gauging from the end of the part to the front face of the chuck until I'm spot on. So let me set that up and we'll get going. Final pass, 1/10 of a mil to come off, which is about there. Good enough for me. Off camera, I've roughed out the adapter. This is the piece that goes in the drawbar for the mill. There you go, that should explain what that bit's going to do. So I just need to finish turn this, and which I'll do off camera because I need to get this really accurate, and the camera being in the way is always tricky. That's now turned. I've given it a reasonable finish. It's the right diameter here, the right diameter here, the right length. Here's a 19mm collet. Fits on there nice and snugly. In here I need to cut a recess to clear the end of the R8 collet, and I want to make a few of these tool holders in the future, so I thought I'll have a go at grinding up a specific tool. So this is ground to hopefully just pop in there and come out and just nibble away. I only need to go down 2 to 3mm, so it's not far, but yeah, we'll see if that works. I've marked the jaws so that I can get the part in the roughly the same position if I need to remachine it. Where have you been? You've been laying in the grass, haven't you? You're just covered in it. Absolutely covered in grass. Marvellous. Hopefully that's not tinted. How lucky is that? Not a bloody mark on it. That's one of the neatest cut-offs I think I've ever managed. That looks good. Buy that. There we go. Tighten that up. This is the feature we're after. That little undercut. You can see it's a 60-degree bit that's 8mm deep. I've got a 135-degree tool, and I'm going to offset the cross slide at 30 degrees. It's not critical, this angle, it just has to be anything over 45 I would have thought would be good. Tiny bit of clearance. I've done a quick trial assembly. That works a treat. The adjusting mechanisms, these 4 grub screws for taking out the eccentricity, they're only done up finger tight. That's really good. What I have done is left off these parts are finished. That's the end cover's finished, the main body's finished, and this is the adapter is nearly finished. I've left off the flat section and the threaded hole for a phono connector. So with that to one side, the next piece to do is what I'm calling the spider. This is the actual the kinematic probe section, if you like. This is the kinematic section. So what we've got is a circular part with 3 6mm holes in it, 120 degrees apart, and in those holes we will fit this acetal rod, and then we'll bore out the acetal rod and fit 3 of these hardened pins that came out of DVD players. They are quite hard, these things. I doubt I could bend one if, yeah, wouldn't make sense not to, but there you go. And I have here an old piece of stainless steel to make this out of. I thought stainless would be good because the internal mechanism is too easy to rust, so I thought, yeah, I've got a bit of stainless, so just need to get this piece off the end, and then we can machine this down to diameter and then put it on the mill and start indexing round and drilling the holes. The trouble with stainless steel is it work hardens when you're cutting it, so that makes it tricky to cut, because it absolutely ruins your cutters. So this is, I find, is the best way. There we go. Piece of cake. Well, do you know, I regret doing that. I'm not quite the man I used to be. Here's my setup for drilling the holes for the kinematic pins, and what I've done is this chuck doesn't run hugely concentric. I probably need to do something about that in the future. Keep watching, you never know. So what I've done is I've just clamped the bar in the ends of the jaws, and I've come out to the I put a little tiny countersink in this end of the bar, and I've got the tailstock support up and running. So because this is fixed and can't move, it will support it this end stationary, but this end can wobble a little bit. So the net result is, if I just spin this chuck, we're down to about 0.01 of a millimetre run out. What I've done is put a point in the machine spindle, and it's now lined up. Let me turn the spindle off. It's now lined up with the very end of this workpiece. I have to excuse the cat, she's demanding. Right, so I've zeroed my axis. Now I need to come down here, I think it's 17 millimetres. Right, there we go, 17 mil dead. Right, off camera I will just change the tools and open that hole out to the half the diameter of this bar, which is 10 millimeters, with a 6 millimeter drill. I've got my little bit of acetal rod in my collet chuck. I'm using an insert for cutting aluminium, which is brand new, seriously sharp, hopefully. And this is what I'm making. Once you've got it down to the tool to the right depth, you can just part these, or just machine these in one hit, so they come out identical. So I just need to make this last one. There are my 3 pins. Let's just put them where they're not going to get greasy. I'm using penetrating thread locker. It's the following day and those little blighters are well and truly stuck. There we go. Pleased with that. That's come out really good. I'll just go round and do the other 2 holes at 2.9 millimeters, and then we'll go back in with a 3 millimeter. So let me do that, and we'll catch up when I've done them. Right, here's the bar. Do you know, that's it. This is what I'm calling the spider. This is the pins fit in there, 3 of them. They're a lot shorter than this, and then they rest on the balls for the kinematic movement. This needs a little bit more work to finish it off. Oh, there we go. In the meantime, I'll get on with that, but I need to do a couple of other things first. Right, here's the body, and I've 3D printed what I'm calling a stator. I don't know if you can see that very well, but that's certainly, it's just come off the printer. It needs a little bit of work. So that fits in like so, and when the spider tilts, what it does is it makes sure that when this crud is all out of here, when it settles back down again, it guides the pins back onto the top of the ball bearings. So so it stops, because I don't know if you could appreciate, but if you push the probe in, you could rotate it. There's nothing to stop that happening. So this is basically there to stop it rotating. And what I'm going to do is just Loctite it in once I've proved that it all works. So yeah, I need to clean that out. I need to finish working this to the right shape. However, in the meantime, there is my palette. Here's a piece of circuit board. So I'm going to use the super glue and tape technique to hold this in place, and I will get that done and then put it on the mill, and we will start to I'm going to isolation route it, which means I'm just basically going to use a very a sharpened engraver to cut out the shape of the circuit board. Yeah, I can't be bothered to send the file off and get one made because I'm lazy. Here we are. I've partly cleaned this this circuit board up. The eagle-eyed of you will have noticed that if I just show you down here, these pads are connected together. I didn't use a fine enough tool to do the engraving, so I will just Dremel out between there, and between there. The balls seem to fit quite nicely. The bar in the spider, the part I'm calling the spider, the actual actuator in the middle sits quite nicely across there. I've cleaned it up, this circuit board, after soldering the balls on, and it looks to me like that's worked quite well. The balls are well attached, and yeah, looking good. I don't know if you can see very well, but I did overheat the board there. I rechucked the part that I'm calling the spider. That's where the pins fit in. So I've rechucked it in the 4-jaw, got it running concentric, and roughed out where this PCB fits. I'll turn it around so you can see. There you go. That's the wrong way round, but you can see the pins coming out of here will bridge the balls on that side. Off camera, I blacked the body and the bits that need to be blacked. Here are the parts all laid out. There's the probe, there's the base cover with the 3 screws, the printed circuit board, what I'm calling the spider, with the kinematic pins in it, insulated pins, spring to hold it all together, a insulated spacer, a spacer to apply the right pressure on the spring, the body, the adapter to go into the mill, and the phono plug. And you only need 2 tools to do it up, a 1.5 and a 2mm Allen key. First task in assembly is to add this spacer, araldite it in place, and make sure that the slots line up with the screws. Yeah, I thought I'd give you a quick demo of how these kinematic probes work. You'll have to ignore the sound of the bumblebee. I think there's one in here looking for a home. So here we have multimeter with continuity, and if we look at these balls are not connected together. However, if I find a piece of the rod and we lay the rod in, then it is connected. Hopefully you can just about see the resistance. So if I touch the probe, it goes open circuit. If I release the probe, it measures a resistance, and that will do that in any direction, including Z. Oops. It does need the spring pressure to make it reliable. I found a phono lead which I've connected to my multimeter. So we plug this in, we get a signal. Touch the probe, takes the multimeter a second or two sometimes to react, but that's getting there. So let's take this over to the lathe and we'll have a little look at it. I've put my thousandths into it. Well, actually this half thou indicator. Is that right? Half a thou. Yeah, 0.0005 of an inch. Is that half a thou? I'm not really sure. Anyway, it's what I've done is I've preloaded it so that it's the stylus is touching the end of the ball probe here, and if I plug my DMM in, you can hear that we have a connection still. So what we're looking for is just how far that has to move before it breaks. Not a lot. I'm going to stop this video here because it's getting pretty long. I think it's 28 minutes or so, and yeah, there's only so much you can watch of me. So thanks for watching. Do hit the bell and subscribe banner, and you'll get notified next time that the next video goes up. Just as a matter of interest, I have done some testing on this, but that will be in the next video because otherwise it would just be horrendous, horrendously long. I don't have a proper ring gauge, a reference gauge, but this is a piece of 50mm internal diameter hydraulic pipe from a hydraulic cylinder, and as far as I can tell it's pretty much 50mm, and once this probe was calibrated I could measure this, not completely repeatably, but I got it to 50.003 maximum and 49.997 minimum. So we got a 0.006 of a mil discrepancy, which is pretty good considering that my mill has only got a repeatability of 0.02 of a millimetre. So it's an order of magnitude more accurate than my mill, I think. So yeah. It's looking quite promising, to be perfectly honest. It seems to be reasonably reliable. It's quite robust. It's got quite a travel on it, an over travel. It's looking good. Next time we'll do some testing on this, and I've also got, hopefully, if it works, coming up a cheap way, I mean a really cheap way of making breakable probes. So that the big thing with these probes, I think, is if you run it into the machine, you don't want to break the body or the mechanism in here. You want to smash the probe, so the stylus, I should say. So that's coming up. So stay tuned. Thanks for watching. This has been an absolute blast making this. I've really enjoyed it. See you next time. Look after yourselves.